Yeah, hi everyone. I'm Alan Busier. I'm a lead software developer in the CG software department at Moving Picture Company, or MPC, in Vancouver, Canada. I've been in MPC for about a little over 2 years now, and before that I spent about 18 years in video game development. So this talk's going to be a little bit different from most of the other talks here at CppCon. I'm not going to be talking about C++17, and I'm not going to be talking about new template meta-programming techniques. It's not even going to show you any code, unfortunately. So what I really want to talk about is just how C++ is used in visual effects. So you don't really hear much about C++ in film. It's mostly discussed in other industries. But C++ does really play a key and important role in the creation of most of the big features that are in films that are in theaters today. So structure of the talk, who we are, a little bit about how we use C++, and then we'll get into the bulk of the talk, which is about our project called Machi, what it is, how it's sort of structured, and I'll dig into a few of the interesting technical and artistic problems we met along the way. And then we'll talk about what we're going to be doing with it in the future. So, by the way, I stole some slides from the marketing guy, so if you want to play like which of the marketing guy slides, I'm cool with that. So this is a marketing guy slide. So when you think about visual effects companies, there's probably a few that come to mind. Unfortunately, outside of the visual effects industry, most people, a lot of them haven't heard of MPC. We're actually one of the largest VFX companies out there. We work on many of the biggest films each year. We've got 9 locations in the world, 5 of which are focused on film. I say we're one of the largest. It's possible, depending on when you ask and what metric you use, we may be the largest. But I'm not going to claim that today. I'm just going to say we're pretty big by VFX standards. We work on a lot of films. Sometimes it's only a few shots. At the other end of the spectrum, we'll do almost the entire film. We've won a couple of Oscars for the best visual effects. The first was in 2013 for Life of Pi, and just this year we won for Jungle Book. We did about 90% of that film. On top, actually, up there, that's my favorite scene. And before we talk about Alien, I want to talk a little bit about this scene. So, I mean, how much of this is CG? Almost all of it, right? I mean, the only thing that's not CG here is the kid. That's it. So, I mean, it's kind of crazy. But think about what went into this scene. Like the background there with all that foliage in the jungle. All of that was placed by an artist, but it was placed using procedural techniques. The water, there's fluid simulation going on. Every strand of hair in the fur, that was generated procedurally using artist-created guide curves. And of course, one of the things to note is that the water actually floats correctly under the water and it maps down correctly above the water. And it's all sort of rendered using shaders and so forth that make it look really realistic. There is a huge amount of code going on here, and a lot of it is C++. And by the way, not all of the kid is real. Look at the legs. CG legs. I don't know why, I have no idea. So first I want to talk a little bit about what languages you use here, or use at MPC, and how C++ is really at the core of it all. We use C++, Python, those are our sort of big two. Lua and Fabric Engine are in there as well. You probably haven't heard much about Fabric Engine, so I'll just give you a quick introduction. It's an application programming framework. It includes a textual scripting language that's fairly high level. It has an LLVM backend, which allows it to generate native code and run fast. And it also has some really convenient semantics built into the language for parallelism and general purpose GPU acceleration. It's kind of meant to bridge the gap between a scripting language in terms of simplicity and a compiled language in terms of speed. I should also mention, well, actually, I won't mention it later. I'll talk about it later. So underpinning everything at MPC, we have a library in C++ called Muggins. And we also have a bunch of simulation code. So that really is where our C++ code ends up. The simulation code is things like Alice, our crowd engine, Kali, our destruction engine, and Fertility, our hair system. Muggins, on the other hand, is just a generic library that we use throughout most of our code at MPC. It's been a core component of our stack for about 10 years now, and it's been used on hundreds of films. It provides a bunch of useful functionality and abstractions like various data types all the way from Vec3 up to polygonal geometry, geometry manipulation routines, math libraries, custom data serialization formats. And importantly, it includes something, a rendering abstraction layer. So that allows us to render to a variety of different targets, such as OpenGL or Pixar's RenderMan, using the same higher level code. I can't show you Muggins. If you're really interested in this sort of thing, there is actually a open source library called Cortex, which is very similar. One of the original Muggins developers went to a company called Image Engine, and he made an open source version of, an open source visual effects library called Cortex, and it shares a lot of the same design choices. So if you're interested in this sort of thing, check that out, because it's open source. So we have a lot of languages. We also have a lot of bindings between those languages. That also means, actually, we have a lot of code to help automate the creation of those bindings. In the middle, we have Lua. That is really the business logic around most of our complex data types and how we get that data onto the screen. It binds mostly down into C++ through Muggins and uses that rendering abstraction layer quite substantially. It's high level enough that a technical artist can contribute to it, and it gets run behind the scenes in a lot of different places. It really only binds down to C++, though. We also have Python. Now, a common pattern at MPC is we write the stuff that needs to be fast in C++, and then we wrap Python bindings around it with Boost Python, and then we control the higher level code in Python. We also use it for a lot of stuff like UI and pipeline code. And of course, we have Fabric Engine over here, which I talked about earlier. It mostly just binds down to C++, but we also have some bindings back into Python for our asset management system. I should actually also mention, I'm using a Mac here. We use almost strictly Linux in our development, which I don't know if that's interesting to you or not. So we talked a lot about languages. Let's talk about aliens for a little bit. So we began work on Alien Covenant. We knew there was going to be a big city in the film, the Engineers City. We even had a concept image roughly showing us what it was going to look like. We'd done a fair bit of work in the past with cities on a number of different films, but this was looking like it was going to be bigger and with a lot more detail and a lot more shots. So it was kind of scaring us a little bit. We knew the rough parameters. We knew it was going to be from a few thousand buildings to maybe tens of thousands of buildings, circular in shape, but maybe with some organic bits at the edges. There was going to be districts, so that meant more residential here, maybe more temple-oriented here, or something like that. And we wanted to basically have a few key hero buildings that we wanted to place in the world. So, for example, a giant cathedral or something like that. And we had to build our city around that, regardless of what we chose for the shape of the city otherwise. So the concept art was only going to be a rough guide. We wanted a way to experiment with various city looks and layouts without requiring an army of artists to manually place buildings every time we iterated on it. We needed a very quick iteration cycle. Build the city, get some feedback, do it again really fast. So, programmer slide, by the way, not marketing slide. Next, we had to choose, do we use an off-the-shelf tool for this, or do we write our own? There were plenty of toy programming examples out there and some really interesting plugins. And then there was City Engine, which really, it's a tool designed specifically from the ground up for generating cities. Unfortunately, our artists had evaluated it. There was a couple reasons we didn't end up using it. One was that it was really kind of centered a little more around urban planning and less around creating alien cities. And the other one was one of my favorite aspects of City Engine, which is CGA shape grammar. For those who don't know anything about it, it's an amazing language that the City Engine team developed. It's a way to define parametric architecture through shape transformations. But to an artist, it's all textual, and to an artist, that's really daunting. That's just not how they want to work. So they asked us to deliver something that was really artist-focused and had really creative inputs. So, buy or build is the sort of question that you face a lot. We definitely have sort of a proudly not invented here attitude at MPC. We try to use third-party software where we can, but there are times when it makes sense for us to write something new. We wouldn't write Maya again, for example. So Kali, our Destruction Toolkit, is a really good example of that, and we won a SciTech Academy Award for that. But in this case, some of the advantages included the flexibility for us to be able to make the tool that exactly what the artist wanted, the opportunity for us to integrate it with other aspects of our MPC pipeline and tool set. And in general, we consider ourselves to be, one of our core strengths is to be proceduralism. And looking further ahead, we said, we keep on getting more and more requests for CG cities. We would like to perhaps spend the time, these cities keep getting more complex and complex. Maybe now's the time to spend investing a little bit in just starting the road towards developing our own toolkit for creating cities. So I was brought onto the project. Seamus Young has an excellent series of blog posts describing how to create a city completely procedurally without any artist input at all. And I was just so taken by that I decided to create my own version of it. But then I decided I'm going to just go a little bit different, and I started researching road layout algorithms, and I came across Yoav Parrish and Pascal Mueller's papers on city generation. For what it's worth, Pascal Mueller was the guy who went on to create City Engine. So I felt confident that I could at least, come up with something that would work. So what we came up with was a tool called Machi. That's our logo up there. And Machi is a Japanese word. It means town or street, so it seemed appropriate and suitably confusing and non-descriptive, as is the fashion in application naming. So this is a very early iteration of Machi. So this is what I want to show you here. The bottom here, this is running inside of Fabric Engine's Canvas node graph visual scripting tool. Each of those blocks on the bottom here essentially corresponds to a C++ chunk of code, like a procedure. And so by putting these bits together, the artists can build a city. We ended up not exposing that to the artists in the end. What they wanted was something a little bit more dynamic. So we got rid of the node graph, and we created this I like to call it a task-focused UI, basically. So, it's a traditional UI, really. We're going to get back to this question of whether that was a good decision or not, but the main point to understand at this point is that we're still using Fabric Engine, actually, here. We've just hidden the Node UI, and we've added our own UI into it, and we're using Fabric for the actual rendering, but all the core stuff underneath is C++. So there's quite a few layers here. Excuse me. So we basically have a Python layer at the very top. This is really a different way of doing, by wrapping everything in Fabric Engine, we're doing this a little bit differently than how we typically do things in MPC. Typically, we take C++ and we wrap it in Python. Here we're wrapping things in KL, wrapping our C++ in KL, and then we're wrapping that inside of Canvas and then having Python control it. So this was a bit of an experiment at MPC. We haven't done this before. This is just sort of we're trying to figure out if this is a good way to make applications. But anyway, yeah, we have a Python layer which controls the UI. We have that layer in red there, it's Fabric Engine Canvas script. It's just a very small node-based layer which glues a lot of the bits together. We have two layers that were written in KL. One is just really to communicate with the viewport and do things like selection and manipulation and rendering. And then we have MPC Machi, which was a thin wrapper in KL around the C++ code. And all the really good stuff was in C++, where we have things like road layout, trying to figure out where blocks are for each of those roads, and then breaking those blocks into lots, and then putting the buildings onto the lots. Of course, all this required a lot of bindings between languages, and this was at times a point of frustration for us. But the rationalization was that if we could figure out a way to get these Machi libraries wrapped in KL, any application that supported Fabric Engine, we could then drop it into it and have the functionality to create cities regardless of the application. Now, to begin with, we just used the native Canvas editor as our sort of hosting application, but the intention was that we would use it in other applications like Maya and Houdini later on. So back to the original problem. How do you lay out a city procedurally but still keep it artist-friendly? I think the first thing to keep in mind is automation is not necessarily an either-or proposition. It can be a continuum. So, artists would love to be able to press a button and it's done. There's my city. But, typically they're going to want to edit things, and the director's going to want to make changes. So we have to be in the mindset of allowing changes at any point, really. So to this end, we wanted to keep our automation in small, controllable chunks and allowing the artist to take control at any point and make edits to the data as they needed it. So the problem is this becomes a little bit of a liability. What would typically happen in a show is you would lay out your high-level streets, and then you'd create your buildings, and then an artist would say, okay, that building wants to be, maybe I'll change the number of floors on it, for example. Then the director comes along and says, okay, the city's not going to be circular, it's going to be square. So go back to the beginning, lay out the streets again, create the buildings again. What happens to that one building that you just edited? Now, in many cases, it's fine. You can just throw it away and start again. But in certain cases, it isn't. You actually want to keep that building. So in our case, we tried a few different things. I think the simplest and most helpful approach for us was just to allow artists to lock down data at any point. You could say, I don't want to change this building or this road. And then what we would do is we would clear out everything else, regenerate the city, and use that data that was locked down as seed data to build off of. So we'd actually, these roads are locked down, build roads off of them, and we would go from there. So I want to talk a little bit about the 15-second demo that we came up with. So at a big studio, artists can be skeptical about embracing new technology. They love their tools. So even if they asked for you to develop a new tool, you still have to convince them to use it. So our goal was to try and make it as simple as possible. Something like 5 clicks to actually create a city, and instead of a 15-minute tutorial, something like a 15-second tutorial. So we wanted to show them the power as quickly as possible and let them explore it later. So we set up a bunch of defaults and just kept in mind as we were designing the UI, keep it simple. So this was a huge success to getting people excited about the project. So I'm going to talk about an interesting artistic problem we faced along the way. One of the first problems we ran into was a mismatch between lot and building sizes. So when we originally wrote Machi, we used a very simple algorithm for creating lots from blocks. So these are 4 roads, basically. The standard algorithm is take the longest edge, divide the thing in half, and keep doing that with a little bit of random variation until the lots are the size that you want. The end result is very evenly sized lots. This actually is kind of how it works typically in a Western city. North America, you'd often divide against the shortest edge first so you can get like a back alley. But a European city, you'll see that play out all the time. Problem is, that would be fine for many cities. It really wasn't going to work for alien. Their buildings, this works great when your buildings are all the same size. But they wanted to, they wanted to author their own buildings, and they did not want them scaled. So we had a wide variety of things that we had to place into the city. And an early test with sort of even just a simple slight changes in size was showing us we needed to do something about making the city more dense. They really wanted it to be a tight feeling city. So our first iteration on that was to basically try and get a little bit smarter and to try and think about using more of a texture atlasing algorithm. We wanted to decide, here are the buildings that we're going to put on the block first, and then divide it up so that those things fit. And this worked kind of. It wasn't perfect. There was still a lot of feedback that it was still too open. They wanted a cramped, tight-feeling city. They didn't want the center entry areas in the middle of blocks. That was fine. But they wanted it really, really dense. So we went back to the drawing board, and we came up with this idea for, we just threw out all of the work we'd done and said, let's just do this dart-throwing algorithm. So let's just try and find a random place on the block, put a building down. If it fits, great. Move it up closer to the road. And just keep doing this over and over and over until you can't fit any more buildings. It was embarrassingly stupid, but it was exactly what they wanted, so that was great. There are some downsides to it. We don't have too much time to go into. It ends up favoring smaller buildings is really the problem, but I had other code that we could use to compensate for that. Here's an early untextured test render showing this sort of nice level of density that we achieved. Another feature we kind of added in towards the end was we have a scatter system that we use. You've seen it in Jungle Book, basically. It's just a system of putting tens of thousands or hundreds of thousands of things down in the world really quickly. But when they tried to use it on the city, they realized they were getting trees in the middle of buildings and so forth. So we built this sort of city-aware scatter system where you could drop down trees, for example, and it wouldn't be in the middle of a building. It wouldn't be in the middle of a road. Or eventually the city had to be a little bit decayed, so they wanted to be able to drop down chunks of concrete that were within 2 to 3 meters of a building, or pieces of shrubs that were only on the tops of buildings, and we could support all of that sort of stuff. And you can see some of the interesting variation on roads I've got here. This is just some test data. It wasn't really final data at all, but I've got straight roads, circular roads. Up on the left, there's some organic roads. So a couple final shots in the film. The city was using sort of close to, I think, about 400 shots in the film. There was only 800 shots that we worked on, so it was used in almost half of the shots that we did. Most of those are more background shots. This was one of the few shots where it was actually sort of showing it in all its glory. I think the only thing, there is some real stuff here. I believe those mountains, at least some of them, might be from New Zealand, but otherwise it's all, of course, CG. Here's the same shot you saw earlier, but the final version of it. A lot of clouds here, obscuring the city. Artists hate that. Well, some artists hate it. The comp artists love putting clouds in, but the guys who get their stuff covered up, they hate that. We had a lot of back and forth discussions. We basically met with the artists and the CG supervisor twice a week at the early start of the project, try to prioritizing very quickly about what their needs were. It was kind of like Agile on steroids, but it worked. The only problem with that is that we ended up, we brought on some design debt, really. A lot of our focus was very much towards Alien Covenant, and when we go back and revisit this for the next series of films, we're going to want to sort of take out some of the alienisms in the software and make it a bit more generic. So I mentioned it's in the background of a lot of shots. This is a great example of it being in the background. There's a really beautiful city shot here. Look at that thing. It's great. But then they went and just messed it up by putting like a big alien and a spaceship in front of it. So I paid good money to see that city, so it's a bit annoying. But anyway, it's nice. So yeah, moving forward, this was the first film we used Machi on, but there's quite a few films coming down the pipeline. And as I mentioned, we have some design debt that we have to address. So a few key areas that we want to focus on. The first is getting back to what I talked about earlier, this question of node-based versus task-focused UI. I am a big fan of node-based programming, and we do that a lot at MPC. We have Katana, we have Houdini and Nuke, all of which are node-based packages that we use. And it's great because you can put things together in ways that you may not have envisioned originally, and you can come up with interesting and unique results. But ultimately, node-based UIs are a way of asking your artists to become programmers. And that works for many artists, doesn't necessarily work for all artists. So I'm still a little bit on the fence about how to approach this, but I'm definitely leaning towards revisiting the node interface and maybe trying to blend the two approaches a bit, and by authoring custom UIs that control nodes and exposing those nodes. Procedural buildings is something that we really didn't do too much with. Most of the buildings that we had on Alien were actually just authored directly by the artist. They didn't want to do anything procedural with them. They just wanted to give them to us. But we did have this system built into Machi where you could specify the base, the roof, and a bunch of floors in between and have random variations for them. And then we would build up buildings out of that. We'd like to go further with this. I think it's a great way to add random variation to a city. CGA Shapegrammar from City Engine is the perfect example of how this sort of thing works, where you can parameterize an entire city really nicely. But it's definitely still too complicated for the average artist. So we're looking at ways that we can, have the artist generate chunks of geometry and then define using C++ code wrapped with KL in interesting ways to maybe make it simple enough for the artists to define rules for how to put those pieces together and expose parameters that then we can procedurally modify throughout the city to add variation. So finally, integration with other apps. As I mentioned, we used Fabric Canvas as our hosting application for this, but we really want to expand out to hosting it inside of other applications like Maya, Houdini, and maybe even some game engines like Unreal. So maybe we could do something like lay out the streets and buildings with Machi, and then inside of Houdini we could take the geometry or the roads that were generated and create actual street geometry, and then we could maybe take it into Unreal and preview it in real time so that we could figure out the right shots that we wanted to use in the final film with high quality lighting and texturing. So that's mostly it for me. I hope I gave you some insight into software development for visual effects. I think we have some time for some questions. Yeah.
Can you use the microphone? Oh, yeah, absolutely. Of course. How did the concept artists feel about the tool, and how was the process that worked with that? Because when I've worked in games and such, like, the shots in the games look very similar to what the concept artists produce.
Yeah, in this case, the concept art came at us really early, and we didn't create it in-house. It was actually created by the studio. So I guess Ridley Scott had signed off on it at an early stage, but then he still knew that he wanted to iterate on it quite a bit after that. So we didn't get to talk to the concept artists. I don't really know what their response was to it, but ultimately we still did fulfill the general vision there. It's just that our final city ended up being quite a bit more dense than what the original concept art showed.
Hi, how much time do you guys have from the moment you're tasked with creating the tool to handing it over to the artist?
Well, that's a good question. We spent a lot of the work that I'd done, well, I guess I should say it was about 2 or 3 months of messing about and trying to figure things around. And then we started to work with the production team, like in lockstep with them, so that they would, this is when this sort of twice a week cycle of meeting with them and tuning. So kind of like basically maybe 3, actually maybe 4 months first. And then after that, it was maybe another 6 months of development in conjunction with the actual production team.
Cool, thanks.
So if you're building an internal tool, one of the things that like I've struggled with is we get a lot of feedback, and it's a struggle to sort of incorporate the feedback versus prioritizing what we're working on. I'm assuming that a lot of the times when you guys gave this to the artists come back and they want this and nitpick on this and this and this. How did you guys like prioritize what was most important to focus on in your development and versus fixing the things that the artists wanted, which would give them that immediate feedback?
Yeah, absolutely. I mean, that's what I talked a little bit about with when I comment on Agile on steroids. That was our twice a week meetings. They would come at us twice a week, tell us what they didn't like, and then we would work with them in those meetings directly with our stakeholders to prioritize what was going to happen next. And generally, we found them to be quite receptive to the idea of this is going to take a month. We're going to work on this next month. Right now, we're going to focus on this. As long as you have, key ideas for, well, on this sprint, we're going to focus on this. On next sprint, we're going to focus on that. And you can make steady progress. Generally, your stakeholders are going to be fairly okay with that, I find. Unless something's really critical. Obviously, if there's a bug and they need it tomorrow and it's stopping their work, then you fix it right away.
So I was curious, so you were talking about the artist wanting to lock a building down and then you were going to regenerate using that as a seed.
Yeah.
I was wondering if you could give us some more details on that. Like, would that be the seed generation for your roads, or were they... I would imagine at some point they want to lock down a whole bunch of things, and then you've got all these constraints, and how do you deal with that?
Yeah, I mean, mostly it's road generation that's the interesting aspect of it. I mean, a building itself isn't really, well, roads. We'll talk about roads first. The roads use some sort of, it's kind of a modified L system to lay out the roads. And basically, if somebody locked down a road, we would just use that as a starting point, and we would just generate new roads, starting with the endpoints of those roads that they'd locked down. If a building was locked down, typically, hopefully, in the end, it was still in the middle. If you lock down the roads around it, then it's still going to be in the middle of the block, so that's going to be okay. If you hadn't locked down the roads, then it could end up in the middle of a street later on, which would be bad. But for the most part, it wasn't a problem. And generally, we basically said, it was really easy to lock down a building in a block because you just say, well, this block is going to have these buildings that are locked, and then that feeds into your dart throwing algorithm, and just keep on pumping more buildings in there until it fits, really. Okay. But ultimately, yeah, the cool part was with the city layout, the road layout bit of it, where we actually just used it as a seed point for the new stuff. Okay.
I was just curious what Python GUI library you guys were using for that tool.
The UI is all Qt. Yeah, it's actually it's Python Qt.
Yep.
Yeah. Okay. Cool. Well, if that's it, thank you all for coming.